Okay, so as I mentioned in the beginning of the week, a lot of these lessons are just based on reasoning and doesn't really seem like math, it's more about reasoning. So, that is what we're doing today. We're continuing with a few more concepts in terms of reasoning. Starting with the warm-up was true, false. Okay, so if you did this already, you should have gotten this would have been true, false, false, true, false. If you did it right. Did y'all get those? Okay, let me quickly go through and explain them because I'm sure not everyone got everyone right. If Malia lives on your street, so if P is equal to Q, and then you live on Rico Street, then Malia lives on Rico Street, then P is equal to R. This whole concept is called the law of syllogism, and we'll get to that today. So if P equals Q and Q equals R, then P must equal R. Number 2, you and your friend have the same amount of money. Your friend spends $4 and you spend $6. You and your friend still have the same amount of money. No, that wouldn't be true no matter what you started with. If one's subtracting 4 and the other one's subtracting 6, that would not equal the same amount. Number 3, it was this equation kind of situation. In order to figure out if this is true, you did have to plug in the values. So this would be 3 times 5 plus 2 times 7. Does that equal 39? You'd get 15 plus 14. Does that equal 39? No, this would equal 29, and that does not equal 39. So that is why that one is false. Number 4, 2 congruent segments. So congruent segments means that they are the same length. So we got segment A, segment B, are shortened by the same length. So let's say they're cut right here and right here at the same spot. The segments are still congruent. That would be true. This one, number 5, is kind of tricky, and it touches on a concept we haven't quite got to this year. You may have seen this concept before, but I'm going to draw a triangle. It's saying it's triangle A, B, C. It says the measure of angle A is 75 degrees, so I'm just marking it 75. Angle B is 75 degrees, and then it says that AB is equal to BC. The 3 angles of a triangle add up to 180, so you could even find the third angle. 180 minus 75 is 30 degrees here. But it doesn't even ask about angles, it asks about side length. Something that comes up later this year, you may have seen it before, is that the sides opposite this angle measure correlate to that length. So if this is 75, this side would be the same measure as the side opposite the other 75 degree angle. So these two would be equal, and then this side over here would be shorter than those two sides. It says AB is equal to BC. AB, this segment right here, is not equal to BC. AC would be equal to BC, but not AB to BC. So that is why that is false. Okay, so it has like a wordy explanation here, but I'm going to do something a little bit different, so just cross that out. This lesson is titled Deductive Reasoning. On Monday we focused on Inductive Reasoning, and then on this lesson we're going to be telling the difference between Inductive and Deductive Reasoning. This definition is kind of confusing, so I went to good old Khan Academy and I'm using their explanation. So we're going to look at Inductive Reasoning. So I'm using this bottom space right here. I can actually zoom out. This bottom space on the notes to make my own notes. Inductive reasoning versus deductive reasoning. Okay, so how do you tell the difference? Inductive reasoning will be like a trend and then a generalization. And we'll look at examples if this doesn't make sense quite yet. Trend to a generalization, and then deductive reasoning starts with a fact and ends with a fact. With inductive reasoning, this generalization, like you're not 100% sure that this is going to happen. It's just based on a trend. Like every time I go to football practice, a dog shows up on the field, so I assume at today's football practice, a dog will show up on the field. You're not 100% sure, you're just basing it based on a trend. Deductive reasoning is a fact to a fact. You know that this will be true. So, like, my football practice starts at 6 p.m. every day, therefore, my football practice will start at 6 p.m. today. Okay. Then, we are going to look at these statements. There's 4 questions where we look at whether it's inductive or deductive. I feel like B is easier to tell, so we're going to start there just to make it a little bit easier for everyone. Okay, so it says, every time Tamika has worn her favorite jersey to a football game, her school team has won the game. So that is a trend. It's not a fact, it's just something that has happened. Tamika is wearing her favorite jersey, so she concludes that her school's team will win. Generalization. It's an educated guess based on a trend. So, trend to generalization, this would be inductive reasoning. Okay, then we're going to do A now. If a student is late returning a library book, then he or she will be charged a $2 late fee. So that is a fact in a perfect ideal world. And then Chang returned a library book late, so he concludes that he will be charged a $2 late fee. Fact. Obviously, rules, I don't know. I feel like in the real world this could be negotiated, but it's considered a fact here. It's very, I don't know, to the point. And so this would be deductive reasoning. Okay, next example. I'm going to go to the top of the next page. And there's 2 more examples. Determine whether it is inductive or deductive reasoning. Okay, so as I read through this, see if you can figure out whether it's talking about facts or a trend. So Newton's first law of motion states that an object at rest will remain at rest unless acted on by an unbalanced force. Elisa watches a soccer ball roll across the field. She concludes that an unbalanced force has acted upon the soccer ball. Okay, this right here sounds like a fact to me, Newton's first law. And then she concludes that the unbalanced force has acted upon the ball. Fact. So this would be deductive reasoning. Okay, Mrs. Jackson notices that her family's data usage is increasing by approximately 2,500 megabytes of data every month. So that would be a trend. So she concludes that her family's data usage next month will be 2,500 megabits greater. So that would be a generalization. So this would be inductive reasoning. Okay, next. The next example set is something a little bit different. This is called so there's 3 main concepts in this lesson. There's inductive versus deductive reasoning. Then there is law of detachment, which we're getting to now, law of detachment. And then there's one more law. Okay, law of detachment. So, if P then Q is a true statement, and P is true, then Q is true. So what does that mean? So here's our given. If a car is out of gas, that would be P, then it will not start. Q. If a car is out of gas, it will not start. we're told that Sarah is out of gas, so that satisfies P. So then we can conclude that Sarah's car will not start, Q. So P then Q. If you have P, then Q will be true. Okay, so how does that apply to problems? Looking over here, determine whether each conclusion is valid based on the given information. Write valid or invalid, explain your reasoning. Okay, given. To go on a field trip, a student must have a permission slip. So this would be P, Q. Mariana turned in her permission slip, so she satisfied P. So then, therefore, Mariana can go on the field trip. This would be the conclusion. And yes, that would be valid since she satisfies that she turned in her permission slip. Did I read it backwards? Student must turn, I think it's worded backwards. Why do they make this confusing? It's already confusing enough. This would be P then Q, but it's like, yeah. Okay, turn in your permission slip, you can go on the... So hypothesis, if you turn in permission slip, you can go on field trip. Therefore, since Mariana turned in permission slip, she can go on field trip. Okay, next. This one comes out to an invalid conclusion. So if a figure is a square, then it is a polygon. Cool. P, then Q. Figure A is a polygon. So their conclusion is that it is a square. Well, this satisfies Q, but it doesn't satisfy P. You can't conclude it backwards like that. So our hypothesis, if a figure is a square, then it's a polygon. But figure A is a polygon, they're going to Q and not P, so figure A, if it's a polygon, could be a triangle. It doesn't have to be a square, so invalid. You can't conclude that figure A is a square. Oh, sorry, that was those. Okay, next. Oh, not yet? Okay. I'm sorry. For some people this may seem easy, for some people it may seem hard. I guess it depends on how your brain works or is wired. Okay, next. I just have one more page. We're going to do these two examples, and then I'm going to do a little note sesh down here, and then we're done for today. So, first one, it says, determine whether the conclusion is valid based on the given information, select the correct answer, and justification. Okay, it says given, if 3 points are non-collinear, they determine a plane. Yeah, that's true. 3 non-collinear points determine a plane. It says points A, B, and C lie in plane G. Okay. Conclusion, A, B, and C are non-collinear. Well, they might be, but they also could be, if A, B, and C are in a plane, they could be collinear. So we can't conclude that they're non-collinear. So this would be invalid. So cross those out. Invalid. A, B, and C determine a plane, therefore they are non-collinear. It's invalid because A, B, and C can be collinear and lie in plane G. Okay, next one. if Dakota goes to a video game store, then he will buy a new game. So this is P, then Q. If he goes to a video game store, he'll buy a new game. Dakota went to the video game store, so P is satisfied, therefore Q will be satisfied. Dakota bought a game, this is the Q. Cool, it all works. So P then Q, he goes to the video game store, he buys a new game. So all of this is valid. So valid because the statement Dakota went to the video game store this afternoon satisfies the conclusion of the conditional statement. Valid because Dakota went to the video game store this afternoon satisfies the hypothesis. Okay, it's this one. Dakota went to the video game store, that is P, the hypothesis, and the conclusion is true. Okay, so, in summary, law of detachment. So, in summary, if P then Q, if P is true, then Q is true. So it gives you a statement with conditions, gives you something that satisfies P, then Q must be true. Okay, the next law, and like I said, we're only filling in this bottom spot right here. Oh, sorry, zooming out. I guess I can. Okay. Next law is, last law, law of syllogism. Weird word. I don't even know if I'm saying that right. Okay, so if P, then Q, and Q, then R, then P must also equal R. And I'm going to give you a situation that satisfies this as an example, and I'm going to try to abbreviate as much as I can. What? If P is true, then Q is true. See. Okay. So just if P is equals R, Q equals R, then P must equal R. So, for example, if you get a job, then you will earn money. True. Second one, if you earn money, then you will get a car. Okay, cool. So therefore, if you get a job, you will get a car. And that's it. Okay. The homework is only 5 questions again. However, you'll likely need some support with the homework. So if you find things that are confusing that you want some help with, please raise your hand or work with your neighbors as much as you can. We have laptops today, so you'll grab a laptop, work on the homework. Once you finish the homework, work on Alex, because we're already midweek, so you should be midweek done with Alex. And yeah, go ahead and get started. Let me stop recording here.